Welcome to Ask and Learn.
Box that slides down a slope at 5 feet per second. And we want to find the horizontal distance it travels after it leaves point B and right before it hits the car at the very bottom at point C. So we're given a few pieces of information. So we're given the weight of this box, which is 10 pounds. We can convert that to mass by dividing by 32.2 feet per second squared. So for the mass, we get 0.31 kilograms. We're given, of course, the initial velocity we'll call v1, and that's 5 feet per second. And this little box experiences kinetic friction from point A to point B. So the coefficient of that kinetic friction is 0.2. So we know that the horizontal distance x, the equation, will equal the velocity in the x direction times time. So we want to find the velocity after it leaves point B and the time it takes for that box to reach the bottom at point C. So because we're dealing with forces, right, work is force times distance. So that box is producing a work and it has a velocity, so it also has kinetic energy. So we can use the work energy principle, and this part is to find the velocity. So we have the initial kinetic energy plus the work being done by the forces will equal the final kinetic energy. Now let's expand the kinetic energy. So we have for T1, we have 1/2 m v1 squared plus, for now just leave the work alone, is equal to 1/2 m v, and the final velocity we'll call vb squared. So this is what we're looking for. So next let's look at the work being done by the forces. So we know the forces involved are the weight of the box and the kinetic energy, or the kinetic friction. So first we have the weight of the box. This is in the x direction times the distance it travels minus, well, kinetic friction. The equation is mu k, the coefficient of kinetic friction, times the normal force times some distance, we'll just call it SF. So to find the weight in the x direction and also to find the normal force, we need to use a free body diagram of the box so that we can see the forces involved. So we know we have weight straight down. We can break this into components. So we have the y component, wy, and we have the x component pointing to the right, wx, and then in the opposite direction of wy, we have the normal force, Fn, and since motion is to the right, the friction is always in the opposite direction. So in the opposite direction, we have force due to kinetic friction. And to find the components of wx and wy, we are actually given a little triangle to make the calculations a little simpler. So we have this triangle, 3, 4 on the bottom, 5 for the hypotenuse. So if we're looking at this little triangle, we're looking at weight in the x direction. We have the weight times the ratio 3/5, and we get this from the triangle. And we know that the normal force is in the opposite direction of wy. So normal force Fn is equal to wy, and so it'll be w times 4/5. And again, get that from the triangle. Okay, now we can plug this in. We have the weight 10 times 3/5 times the total distance this box travels, which is 40, minus coefficient of kinetic friction 0.2 times the weight 10 times 4/5 times the distance it travels. And so the kinetic friction is only experienced between points A and B. So it only travels, or the friction is only experienced for 15 feet. And so plugging this into the calculator, for the work we get 216 joules. Now we can plug this back in to our equation at the very top. So we still have the kinetic energy initial. So we have 1/2 the mass 0.31 times the velocity initial 5 plus the work done, which is 216, is equal to 1/2 times again the mass 0.31 and VB squared. And again, we're solving for VB. So we got VB is equal to, so all this on the left, which is 219.88 divided by 1/2 times 0.31, which is 0.155, and all of this square root to get rid of the square on VB. So for VB, we get 37.66 meters per second. Okay, so that's the velocity. Now we need to find time, and we can do that using a kinematic equation now that we know the velocity. So we can use y final is equal to y initial plus the velocity b in the y direction times t plus 1/2 a t squared. Plug in your numbers. So y final, right when it hits the car, it's actually 5 feet above the ground. So we have 5 is equal to, initially at point B, it's 30 plus, and then, well, we know velocity B, but in the y direction, so we have 37.66 times the ratio 4/5, and of course times t plus 1/2, and a, the acceleration here, since we're dealing with feet, is 32.2, and then t squared. So let's clean this up a little bit and move to the 5 to the right. So we now have 16.1 t squared plus 30.13 t minus 25 equals 0. So to solve for t, we need to use the quadratic equation. So we have t is equal to minus 30.13 plus or minus square root, and then all of this is under the radical. So 30.13 squared minus 4 times 16.1 times minus 25, and again all under square root, and everything divided by 2 times 16.1. So when we plug this all into the calculator for time t, we get 0.62 seconds. So finally, now that we have velocity and time, we know we have x is equal to the velocity in the x direction, so it's 37.66, and since in the x direction we use a ratio 3/5 times time, which we just found, 0.62. So in the x direction we get x is equal to 14.1 feet.